Hello and welcome to ashford.com. You are watching an interesting video on brain signaling pathway that they believe contributes to the development of Alzheimer's. Please read this disclaimer carefully. Exactly what causes Alzheimer's is unclear, which is primarily why scientists have yet to find a cure for the disease. But could this soon change? Researchers from the Mayo Clinic in Jacksonville, FL, have identified a defect in a brain signaling pathway that they believe contributes to the development of Alzheimer's, which could lead to disease prevention strategies or treatments for its early stages. The research team, led by Dr. Guojun Bu, a neuroscientist at the Mayo Clinic, published their findings in the journal Neuron. Alzheimer's disease affects more than 5 million people in the US and is responsible for more than 500,000 deaths each year. Characterized by memory, thinking and behavioral problems, Alzheimer's is the most common form of dementia, accounting for 60 to 80% of all cases. For years, scientists have been working hard to identify the causes of Alzheimer's, which is key to preventing and treating the condition. Past studies have suggested that Alzheimer's can result from an accumulation of a protein called beta amyloid in the brain, which can damage or kill nerve cells. The Mayo Clinic team builds on such suggestions with this latest study, finding that low levels of a protein that regulates beta amyloid production and nerve cell communication interferes with signaling in the WNT pathway, known to be important for embryonic development, cell survival and synaptic activity crucial for memory and learning. From analyzing mouse models of Alzheimer's, Dr. Bu and colleagues found that the mice were deficient of low-density lipoprotein receptor-related protein 6, LPR6. This led to an excess accumulation of beta amyloid and suppressed WNT signaling, which degenerated dendritic spines and synapses and impaired communication between nerve cells. The researchers then analyzed post-mortem brain tissue from patients with Alzheimer's disease. Once again, they identified LPR6 deficiency that had led to suppressed WNT signaling, which they say is likely due to a buildup of amyloid beta. According to the research team, past studies have linked overactivity of WNT signaling to cancer development, but their study is one of the first to associate underactive WNT signaling with Alzheimer's. Our finding makes sense, because researchers have long known that patients with cancer are at reduced risk of developing Alzheimer's disease, and vice versa, says Dr. Bu. What wasn't known is that WNT signaling was involved in that dichotomy. The team notes that when it comes to cancer treatment, drugs that suppress the WNT signaling pathway are already being tested. Although that is not the desired outcome in the case of Alzheimer's patients, the researchers say they could use the findings to identify ways to boost WNT signaling. Dr. Bu adds, identifying small molecule compounds to restore LRP6 and the WNT pathway, without inducing side effects, may help prevent or treat Alzheimer's disease. This is a really exciting new strategy, a new and fresh approach. Dr. Bu adds, identifying small molecule compounds to restore LRP6 and the WNT pathway, without inducing side effects, may help prevent or treat Alzheimer's disease. This is a really exciting new strategy, a new and fresh approach. References: